Ever wish you could write code that, you know, writes more code for you?
Kind of like automating the boring stuff.
Exactly. And that's what we're diving into today, the world of Rust macros.
Ah, macros. They're like powerful, but sometimes a little mysterious, right?
Yeah, definitely can be. But our guide for this deep dive is an article from August 2024 by someone who calls himself Anohu AB1R.
Catchy name.
Right. They describe themselves as a creative tech innovator, and their article on Medium, Rust Macros, a deep dive into metaprogramming, is pretty awesome breakdown.
Metaprogramming sounds intense.
Oh.
So where do they start?
Well, they jump right into what they call declarative macros. They describe them as being like sophisticated code templates.
Okay, so like a pre-built structure you can use over and over again.
That's the idea. It's all about recognizing patterns in your code. Like if you find yourself writing basically the same logic multiple times.
Oh, yeah. I've definitely been there. Lots of copy pasting, hoping I don't forget to change something.
Exactly. And that's what's so cool about declarative macros. You define the pattern once, and then the compiler handles swapping in the specific details each time you need it.
So less repetition, which is always good, but it sounds like a good way to prevent errors too.
Absolutely. And because declarative macros are doing their work at compile time, you're catching those potential issues super early on.
Nice. So before your code even runs. Smart.
Right. Now, Manohu Aba1R gives this cool example with a create function macro. And I have to admit, the first time I saw that macro rules syntax,
It's a bit intimidating.
yeah, I was like, whoa, this is next level stuff.
It's definitely a shift from, your typical Rust syntax.
Totally. But once you get past that initial, what am I even looking at moment, it's actually pretty elegant.
So in that example, you're basically just telling the compiler, hey, I need a function with this name, and this is the code I want inside it.
Yep, and the macro takes care of all the rest. And they use these things called designators, like ident and expra, to tell the macro what kind of input to expect.
Okay, so that's how it knows which parts of the function name, which parts of the code to be executed, and so on.
Exactly. It's like giving the compiler specific instructions on how to assemble the code.
Clever. But how does this play out in real-world projects? Like, I get the idea of reducing repetition, but what are the tangible benefits?
Well, Adahu Abkorar makes a good point about readability and maintainability. Like, imagine you're working with a complex data structure.
Lots of nested fields and stuff.
Yeah. And you frequently need to create new instances of it, each with slightly different initial values.
I can see where that would get repetitive and error-prone fast.
Right. But instead of writing out the entire structure initialization every single time, you could define a declarative macro to handle it for you.
So you just provide the values that need to change.
Yeah.
The macro would generate the full structure initialization.
Exactly. Ensuring consistency, reducing the risk of typos, making your code super clean. It's like having a custom code generator.
Okay, that's a really cool way to look at it. So it's not just about saving keystrokes. It's about enforcing best practices right from the start.
Exactly. And speaking of custom code generation, that's where things get even more interesting as we move into procedural macros. But we'll dive into those after a quick break.
All right, so we're back and ready to unlock the power of procedural macros. Before the break, we were talking about how they give us access to the token stream. Can you remind us what that is again?
Right, the token stream. It's basically, think of it like this. When the compiler sees your code, it breaks it down into individual pieces, right? Like keywords, variable names, operators.
Okay, like the raw ingredients of our code.
Yeah, exactly. The token stream is like that stream of ingredients. And procedural macros, well, they let you step in at that raw ingredient stage and, rearrange things, add stuff, even change the recipe entirely. Now, that's what I call power. So with declarative macros, we're working with these pre-built patterns, but with procedural macros, we can actually write code that manipulates the code itself.
Precisely.
Yeah,
It's like, imagine you're baking. With a declarative macro, you're using a cookie cutter, but with a procedural macro, you're like sculpting something unique from scratch.
I like that analogy, so we can get really creative with it.
Exactly. And, Anohu Ewaratera talks about three main types of procedural macros: function-like, derive, and attribute. Each one has its own sort of flavor.
They do sound a bit intimidating, though, to be honest, even for someone who's comfortable with Rust.
They have a certain mystique, that's for sure. But don't let the names scare you off. Think of them as specialized tools in your macro toolbox. Function-like macros, those are probably the easiest to get started with. You call them just like you would a regular function. Pass in some input, and boom, you get back some transformed code.
Okay, so like that make function example from the article, you just give the macro a name and it generates a whole function for you.
Exactly. And that example shows how procedural macros can actually analyze the input they're given. Like they make sure you're providing the right types of data. They're not just blindly spitting out code. There's some intelligence happening behind the scenes.
That's really cool. So it's doing some of the thinking for us.
Right. It's like having a little helper buddy. Now, derive macros. Those are interesting.
Yeah. Those are the ones that always seemed kind of like magic to me.
A bit of sorcery for sure.
Yeah.
But they're all about automating the implementation of traits.
Traits, right.
Yeah.
Those are like blueprints for behavior that your types can follow.
Yes, exactly. So let's say you have a trait that defines how to display something on the screen. With a drive macro, you could automatically implement that trait for any new type you create without having to write all the code by hand.
Okay, so it's like saying, hey, I want this new type to be displayable too, and the macro takes care of all the details.
You got it. Saves you a ton of time and makes sure everything stays consistent.
I love that. And then there are attribute macros. Those still feel a bit mysterious.
Attribute macros are interesting because they let you attach code to existing items in your code.
Yeah.
Could be a function, a struct, even an entire module. It's like putting a sticky note on it that says, hey, compiler, do something special with this.
So it's like modifying the behavior of existing code without actually changing the code itself.
You got it. Like, you could use an attribute macro to automatically log every time a specific function is called without modifying the function's code directly.
Wow, that's really powerful. But with all this talk of code manipulation, I do have to wonder about the potential downsides. I know who Abby 1R mentioned something called macro hygiene. What is that all about?
That's a great question. Macro hygiene is all about preventing conflicts and unexpected behavior when you're working with these powerful tools. And we'll get into the nitty-gritty of that right after a quick break.
All right, so we're back. And before the break, things were getting kind of serious. We were talking about macro hygiene. It sounds important, like making sure our code doesn't get contaminated or something.
Right. It's more like preventing bugs than, actual hygiene. Remember we were talking about how procedural macros work with the raw token stream of your code?
With like rearranging ingredients before the code gets baked.
Exactly. So imagine a macro accidentally using a variable name that's already being used somewhere else in your code.
Ooh, that doesn't sound good.
Not good at all. That's a recipe for some really weird behavior, maybe even crashes.
Yikes. So macro hygiene is about making sure that doesn't happen.
Exactly. Rust has these built-in mechanisms that make sure variables defined inside a macro stay inside that macro. You know who Abby1 gives a good example in the article. They show how a macro can safely define and use a variable named x without messing with any other x you might have in your code.
Okay, that makes me feel better. It's like each macro gets its own little sandbox to play in.
Precisely. It keeps things organized and prevents those nasty surprises.
Nice. Speaking of things that can get a little wild, you know who Abby1 also mentioned something called recursive macros, and honestly, the name alone makes my head spin a little.
I get it. They sound intimidating, but the idea is pretty cool, actually. Basically, it's a macro that can call itself.
It calls itself. That sounds like a recipe for disaster, like an infinite loop or something.
It could be, but when used correctly, it's super elegant. Think of it like those Russian nesting dolls.
Okay, yeah, I see where you're going with this. But how does that actually work in code?
So imagine you want to write some code to sum up a list of numbers. A recursive macro could do this by saying, okay, I'll add the first number to the sum of the rest of the list. And to figure out the sum of the rest of the list, it calls itself again and again and again until it gets down to a single number.
Wow, so instead of writing out a loop or something, the macro just handles it all recursively.
Exactly. It's a really elegant way to handle tasks that involve repeating a process multiple times.
I could see how that would be really useful. But I do have to wonder, with all this power, are there any downsides we should be aware of, like performance-wise?
That's a really important point. Macros are super flexible,
Right.
and they can make your code way cleaner, but they're not always a free lunch when it comes to performance.
Right, because at the end of the day, we want our Rust code to be both elegant and efficient.
Absolutely. One thing to keep in mind is that while macros do their work at compile time, they can actually make your compilation times longer if you use a lot of them or if they're super complex.
Right, because the compiler's doing more work behind the scenes.
Exactly. And another thing to consider is code bloat. Because macros are generating code, If you go overboard, it could lead to a larger compiled program size.
So it's a trade-off, like anything else.
Exactly. And that's why, understanding when to use macros and when to maybe explore different solutions is crucial.
It's about picking the right tool for the job. Sometimes a simple function is better than a fancy macro.
100%. It's all about finding the right balance for your specific project.
Totally. Well, as we wrap up this deep dive into Rust macros, I have to say I've learned a ton. What about you? What are some key takeaways you'd want listeners to walk away with?
For me, it's remembering that macros are incredibly powerful, but like with any powerful tool, they need to be used thoughtfully. Understanding the trade-offs, the performance considerations,
Yeah.
that's key to using them effectively.
Absolutely. And Inohu Abion leaves us with a really interesting question. They ask, what if we could share and reuse macros as easily as we share libraries? Imagine that. A whole ecosystem of pre-built, ready-to-go macros for all sorts of common tasks. That would be a game changer.
It would be incredible. It would really unlock a whole new level of collaboration and code reuse.
It really would. Well, on that note of exciting possibilities, we'll wrap up this deep dive into the world of Rust macros. We've covered a lot of ground today, from basic concepts to some really advanced techniques.
And we even touched upon the potential future of metaprogramming in Rust, which is pretty mind-blowing.
It really is. Until next time, happy coding, everyone.